Hello everyone, welcome to Mathematics Step by Step. I am Ying. So today we'll learn about undirected graphs and directed graphs, okay? Then weighted graphs and unweighted graphs. We'll compare them. What are the differences, okay? So a directed graph is a graph in which a direction is assigned to the edge connecting two vertices. So let's refer to diagram 1, okay? We can see at the edge here, there's a direction. There's an arrow here, okay? So this is a directed graph. So for example, road maps, airlines networks, electrical circuits, computer networks, and organization charts. All these are directed graphs, okay? Diagram 1 shows a simple directed graph. Why is it a simple graph? Because there is no multiple edge. There's no loop, okay? Based on the directions of the arrows, it can be seen that for edge AB, A is the initial vertex, B is the terminal vertex from A to B, okay? For edge CB, C is the initial vertex, B is the terminal vertex, because we can see the arrow is from C to B, okay? All vertices are connected in one direction only. Now let's see diagram 2. Diagram 2 shows a directed graph with loop and multiple edge. Okay, so in this case, it is not a simple graph. Based on the directions of the arrows, it can be seen that E4, okay, this is E4, P to R. P is the initial vertex, R is the terminal vertex. E5, E5 is here, from R to P. Okay, so R is the initial vertex, P is the terminal vertex. Then E2, there's a loop here. So this is how we write Q, okay? Q is the initial vertex and the terminal vertex because E2 is a loop, okay? So Q itself is the initial vertex and the terminal vertex, okay? An undirected graph is a simple graph or a graph with loops and multiple edges drawn without any direction being assigned, okay? So now, from this table, we will learn about the differences between a directed graph and undirected graph, okay? So this is undirected, this is directed because there are arrows here, okay? Then this is undirected, this is directed because there are arrows here, okay? But we can see these two are simple graphs because there is no multiple edge and there's no loop. But in here, there's multiple edge and loop, okay? So now, let's refer to this graph, okay? So the set of vertices A, B, C, D, because the vertex are named after A, B, C, D, okay? Then the set of edges, we have learned how to write this down, okay? So degrees for vertex A is 2 because there are two lines connecting vertex A. Then degree for B is 2 also because there are two lines connecting vertex B, so on and so forth, okay? So again, sum of degree is equals to 2e. So we can see there are 4 edges now. So 2 times 4 gives us 8, okay? Then now, let's refer to this graph. Again, the vertex are named after A, B, C, D. And this is the set of edges. So now, there's a little bit different here in how we write the degree, okay? Because there's direction now. So, the degree of edges coming in at vertex A is 2. Okay, we can see this is the first edge coming in. This is the second edge coming in at vertex A, okay? Then, degree of out at vertex A equals to 0. We can see there's no edge coming out from vertex A. Okay, so the degree of vertex A is equals to 2. Okay, we add those edge coming in and the edges going out, okay? Okay, then same goes to vertex B, okay? Let's see, there's no edge going in at vertex B, okay? So we can see 0 here. Then number of edges coming out from vertex B is 1, 2. Okay, so we can see here, so on and so forth. Then we came to this answer, sum of degree equals to 8. Okay, then let's see this undirected graph. We can see the edges are named after P, Q, R, S, T. Okay, and this is the set of edges. So now degree of vertex P, 1, 2, so equals to 2. Okay, degree of vertex Q, 1, 2, 3, 4. Okay, so on and so forth. I believe now you know how to find the degree. Okay, so now let's look at this graph. Okay, we can see the edges are named after P, Q, R, S, T also, and this is how we name the edges. So now there's a little bit different here because there's direction now. So the degree of vertex P equals to 1 because we can see the number of edge going in vertex P is 1. Okay, then the number of edge coming out from vertex P is 1. Okay, so on and so forth. So now I want to point out one more special one here. Okay, let's look at vertex T. Okay, vertex T is here, so we can see this loop is count as 1 degree for going in at vertex T. Okay, and it is count as 1 degree for an edge coming out from vertex T. Okay, so number of degree going in equals to 1, coming out is equals to 1, 2, and 3. Okay, the third one is the loop. Okay, so we can see the explanation here. So now what is the differences between a weighted graph and unweighted graph? Later on we will look at examples. Okay, I'll show you a simple one. So this is the first graph, this is the second graph. Okay, so this is a weighted graph, this is unweighted graph because we can see there's no weight here, but there is weight here. Okay, not associated with a value or a weight. So for a weighted graph, it is associated with a value or a weight. Okay, both it could be directed graph and undirected graph. So let's look at the example. Weighted graph example, we can use the edge to represent distance between two cities. We can use to represent traveling time. We can use to represent the current in an electrical circuit and also the cost for, let's say, a flight. Okay, then for unweighted graph, the examples are job hierarchy in an organization chart, flow map, tree map, and bubble map. Okay, so now let's go through example 7 together. Draw a directed graph based on the given information. So A, this is the set of vertices, this is the set of edges. Okay, so let's look at the solution given. So the edges are named after P, Q, R, S, T, U. Okay, then P to Q. Okay, because it says a directed graph. Okay, so we must have all these arrows. Okay, then P to R, R to Q, S to R, S to Q, then S to T. Okay, then B, there's a loop at vertex Q and RS is a multiple edge. So this is the information given. Let's learn to draw. Okay, so from the information given, we know there are 4 vertices named after P, Q, R, S. Okay, so we see at vertex P, number of edges going in equals to 1. Okay, so here equals to 1 going in, then coming out is 1. okay? So from here, you'll have to start from the left, okay? This is the first information that we know. There are 4 vertices named after P, Q, S, R. Then, given that there's a loop at Q and there's a multiple H at RS, okay? Then slowly we can draw this graph like completing a puzzle, okay? So you have to go step by step from the left to the right, okay? So later on we'll look at more examples. Then now let's look at vertex Q. There's 3 edges going in. So this is the first one, this is the second one, then this loop is count as another one, okay? Then coming out from vertex Q is 2. So this is the first one, then this loop is the second one, okay? Then going in at vertex R equals to 0, okay? So coming out from vertex R, there's 3. So this is the first one, this is the second one, this is the third one, okay? Then let's check for vertex S. Going in, there are 3. So 1, 2, 3, correct? Then coming out from vertex S is 1. So this one, okay? So it is correct. So now let's go through example 8 together. The diagram on the right shows one-way paths that Izarul can choose for his running practice. Vertex V1 is the starting position. So this is the starting position. V5 is the ending position. Here is the end. Before he goes home, determine A, the shortest distance from V1 to V5. From V1 to V5. So we can see this is a weighted graph, because there are weights at the edges, okay? So now we want to determine the shortest distance from V1 to V5. Okay, so we will try and error from V1 to V5. So we can see here is 600 meter, here is 500 meter. So when we add up, we get 1100 meter, which is 1.1 km. So this is the shortest distance, okay? The other routes will give you longer distance. For example, from V1 to V3, here is 500 meter, then V3 to V4, 500 meter again, V4 only to V5, 500 meter again. So it would be 1.5 km for this route, okay? So this is not the answer that we want, okay? Then now, B, the longest distance from V1 to V5. So now we want to find the longest distance, okay? So let's see, from V1 to V2, V2 to V3, so 600 plus 900, then to V4, then only to V5, okay? Then plus 500, 500, so we get 2.5 km. This is the longest distance. Then part C, the vertices that must be passed through if the distance of one-way run is between 1.5 km and 2.1 km. So meaning not the routes that we get in A and B, okay? So V1 to V3, V3 to V4, V4 to V5. This is one of the routes that I have discussed with you just now, which is 1.5 km, okay? Then another route, V1 to V2, V2 to V4, then V4 to V5, okay? So 600 plus 800 plus 500 give us 1.9 km, okay? So again, we have reached the homework, so go back, you guys will complete this homework so that all this knowledge that we learned today belongs to you, okay? So if you are struggling in completing all this homework in the textbook, I have prepared an online course for you guys, okay? It is a step-by-step guideline in helping you guys to complete all this homework in the textbook, including the comprehensive practice at the back of each chapter, okay? So coming next, we'll learn to identify and draw subgraphs and trees. So do not forget to subscribe to my YouTube channel so that you do not miss out any of my upcoming videos. I'll see you in the next video. Bye bye.